ultimate goal in solving equations is to isolate our variable. What do I mean when I say isolate? Who knows what that means? What do you think, Leo?
To kind of make it alone.
Okay, so it's all by itself.
Yes.
Okay, so I'm going to write that in parentheses, all by itself. Okay? So we have one side of our equation, so now we need to put the other side, or represent our positive 2. So how would we represent positive 2? What do you think, Corinne?
2 positive signs.
Okay, so 2 positive signs. So here's my variable. I'm trying to get this all by itself. What do I need to get rid of to make that variable isolated? What do you think, Marcus? Okay, so we're gonna take away our 3 negatives. So if we take away 3 negatives on one side of the scale, what do we have to do on the other side of the scale?
Take out 3 positives.
Okay, let's raise our hands. I'm hearing mixed messages. So if I take away -3 on one side of the scale, what do I have to do on the other side? What do I have to do, Miko? If you do take away -3 on one side, we want to do the same thing on the other side. Okay, so Miko kind of jumped one step ahead, but that's okay. If we have 2 positives and we're trying to take away 3 negatives, Miko said we need to add 0 pairs to this so we can take away those negatives. So I want you to add 3 0 pairs. And now we can take away our 3 negatives. So we have our variable out to the side, and it equals what? What does it equal, Jackson?
Oh, I don't know, but why would you do 3 0 pairs? You have 2 positives.
Okay, because we're trying to take away 3 negatives. So I know we have 2 positives already, but in order to take away 3 negatives, we have to add 3 0 pairs to our model.
But you already have 3 negatives. Yeah.
Before I added 0 pairs here,
Yes.
that was on one side of the scale. So we're trying to do the same thing on this side of the scale.
So then, why wouldn't you just add 1? Because then that gets you to 3 positives.
But we're not thinking positives, we're trying to take away negatives.
Oh.
Because we're doing the same thing on each side of the scale. Okay? So what's left in my model here? Go ahead, Lane. Positive 5. So in our variable equals positive 5. Okay? So the models are a little bit trickier. We're going to be working on those with addition and subtraction problems. But this is the way that I like to do it, solving the equation algebraically. So I want us to rewrite it up here in this little box. So n plus -3 equals 2. So when we do it algebraically, we're kind of doing the opposite or undoing the operation that we're doing on one side. So what's the opposite of adding?
Subtracting.
Okay, so if we want to get rid of this -3 and we add it in this side, we need to take away or subtract -3. So if we do it on one side of the equal sign, we need to do it on the other side too. So we need to do 2 minus -3. And when we think subtraction, what do we think of?
Take away.
ATO. So add the opposite. We're adding the opposite of -3, which is +3. So 2 plus 3 gives us 5. So n equals 5. Okay? So do we understand how to do it algebraically? Question, Jackson?
But, so, what did you do with the 3? Subtract it by what?
Okay, so I was adding -3 to this side, so I took away or subtracted -3. So since I did it on this side of the equal sign, I had to do it on this side as well. And when I added the opposite, it changed to 2 plus positive 3.
So what did you add to the negative 3?
To the negative 2,
Oh, 2. Wait, I'm confused. Wait, so then why did you do this step right here? What does that do?
because we're trying to isolate our variable. That's our ultimate goal. So if we want to get this variable in by itself, and we're adding negative 3 on this side, we want to take away that negative 3, so in's all by itself.
Oh,
Okay, good?
Yeah.
Alright. So the next part, simplest part, plot your answer on a number line. Draw your number line. And our answer was positive 5. You can put 6 or some other numbers just for reference. And our very final step, we're going to plug in chug.